The number of positive solutions x to the equation log base 2 of x equals log base 2 of x plus a plus b, where a and b are non-zero real numbers, is, and we've got a bunch of options here, either 0 or 1, depending on whether a times b is positive or, less than 0, positive, less than 1, bigger than 1, that sort of thing. Okay, now there's two ways you can approach this. You can either approach this by drawing a sketch, or you can approach this algebraically. Just because I think algebra is maybe a bit more what we're used to than sketching this graph, especially the one on the right. That might be a bit tricky. Let's just approach this with algebra. If that doesn't work, then maybe we can think about doing this via a sketch. Okay, let's try and solve for x here. Let's raise both sides to the power of 2. So I get x equals 2 to the power of log base 2 of x plus a times 2 to the power of b, and that is the same as x plus a times 2 to the power of b. Okay, cool. So let me just rearrange this. So if I expand the right-hand side, I get 2 to the b times x plus a times 2 to the b. And bringing all the x's on one side and then dividing by the coefficient, I get x equals a times 2 to the b divided by 1 minus 2 to the b. And you may go, well, surely this just means this is always soluble and there's always a solution x. But we do, of course, need to ensure that this value of x is positive. So if x is positive here, well, how can we guarantee that? Well, 2 to the b is always going to be positive, regardless of what b is, because b is a real number, 2 to the b is positive. So we just need a and 1 minus 2 to the b. We either need them both to be positive, or we need them both to be negative. Okay, so if they're both negative, i.e. if a is negative, then what do we need here? Well, we need 1 minus 2 to the b to be negative. That just means 2 to the b has to be pretty big, just bigger than 1. And that just means b has to be positive. So either we have a is less than 0 and b is positive, or the other way around, which would be a is bigger than 0 and b is less than 0. And so if you notice in both those scenarios, one number is positive, one number is negative, and so therefore, either case, we need a times b to be less than 0. And if we do have a times b to be less than 0, we get precisely one solution, namely this guy here. So the answer here is going to be one solution if a times b is negative, and 0 if a times b is positive. So the answer here is C.